everybody. Come on, we need to be a little livelier. If you guys have cell phones, if you can just put them on silent, please, so I don't get interrupted by a duck sound or something in the middle of my seminar. Today we're going to talk about basic diesel maintenance in the Great Lakes. The reason that I say in the Great Lakes is because most of your standards are written for boats that are in the water 24/7 and year-round, and we do things a little different. And before I get started, I would just like to introduce myself. As you can see, my name is Mark Tisch. I've worked with Larson Marine for 20 years. Prior to working at Larson Marine, I was in the Navy for 20 years. And prior to that, I grew up over in Sandusky, Ohio on Lake Erie. Been boating pretty much my entire life. Seminar today is to teach you basic maintenance. If you have a question during my seminar, please feel free to ask. I will repeat your question so that the people in the back understand what I'm answering. And in addition, what I talk about today is the practices that I've used over the last 20 years and that Larson Marine has used basically over the last 40 years, because I did it in the service as well. But it's just things we've done that's been successful. There's more than one way to iron your clothes. There's more than one way to do several things. I simply talk about the practices we've used and what's been successful for us. So as I said, feel free to ask questions. How many power boaters? Okay, a couple. That's fine. It usually happens. We're prominently sailboat marina here. Anyways, I'd just like to know. So with that said, how many Cummins diesels we got? Caterpillars? Okay. Perkins diesels? Fun to work on, isn't it? Yanmar? Okay. Volvo Penta? I knew that was coming from you. What else? Westerbeek? Beta? Just trying to get an idea of what kind of diesels that everybody has. Basically, diesels are diesels. They're all going to pretty much run and have the same components and things. Just the ones in the power boats are much bigger and actually have a few more features. Diesels have changed a lot over the years. Our EPA regulations have required mass changes. A lot of folks and customers we have here that are sailboaters have older sailboats, which I don't know if you ever noticed that, but we have several 1970-something sailboats out here. We have very few 70-something vehicles sitting out in the parking lot. Huge difference. And sometimes when I'm talking today, I'll refer to your boat, your diesel and your car, because you're very familiar with your car, and I can kind of give you the similarities between it just to help you understand it a little bit better. Okay? So, section 1 is the engine components. As I was just saying, most of your diesels are pretty much the same, and you can look at this. If anybody, I get this question a lot, would like to have a copy of this slideshow, just contact me afterwards, and I'd be glad to email it to you, because I know you can't pick everything up as we're going through it. But those are, as I said, just your major components of your diesel. So once your engine starts running, everything that produces the power comes down through the crankshaft here, which leads out to your transmission, which goes to your propeller that makes your boat go through the water, hopefully, if you've maintained it properly. I got this little slide in here so you can kind of see it's kind of nice. It's got this animation in here of how your engine works. It all starts on the intake of air, which is here. The air comes in, the piston goes up, it squeezes it, and the fuel goes in just before it gets to top dead center, which causes an explosion. It's an actual explosion in your cylinder. It forces the piston back down, the exhaust valve opens and the exhaust gases that aren't burnt go out. And this is just a continuous cycle, goes on and on and on, and it's basically a very simple way. I learned this when I was in the service, and I've been teaching it for years, and it's very simple. If you start with this, suck, squeeze, pop is the explosion, and blow is the exhaust going out. That's how your diesel runs, very simple. To me, it's very simple, but yet, sometimes you get into gasoline engines and all the electronics, and that gets confusing for me. So, a diesel mechanic or a gas mechanic, a lot of similarities, but this is very simple. So you take one of those away, your engine's not going to run. If you have a restriction in air, your diesel might not start up. Or if you're not careful or looking around, or you leave a rag laying in your engine compartment, you can suck it into the intake, and it'll shut the engine down like that. Because you need air, heat, and fuel to run this engine. Heat is done by compression, which is as you turn the engine over with your starter and the piston starts going up and down, you're creating heat because you have friction of metal against metal in there. You have a set of rings in there, which was on the last picture, but these lines right here, those are your rings. So they are positioned. Usually you will have 3 compression rings with the split in the rings staggered at 6, 12, 3 o'clock. And then the bottom one is called, it almost looks like a double ring, it's called an oil wiper ring. And so as the bottom of the piston is being lubricated, which you'll see in a thing later, the oil comes up, and inside the cylinder it needs to go back to the sump. So the wiper ring actually pushes the oil back down to the sump. Yes? Did you say on continuous rail? The basic operation is still the same, yes. He asked if it's like this on basic rail. The basic operation is, you're still going to suck the air in, you're going to squeeze it. It's just the way the fuel injection works is a little bit different, and that's a little more complex. We can get into that on a one-on-one discussion if you'd like. But basic operation for the general purpose of everybody, I just wanted you to see how all of this works so that as we describe and go through the components, that everybody will understand. So we're going to start with the fuel system. Very old drawing, but very basic and simple. You have a fuel tank. And then missing in this picture, but this is an old presentation, and I've left it missing for the purpose of showing the importance of it, is between your fuel tank and your lift pump, be it a manual lift pump or an electric lift pump. All engines are different. Mostly your Westerbeek and your Universal smaller diesels have electric fuel pumps. Volvo Penta sometimes has it. I think Beta might have it, but a majority of them have a pump like this. There's a diaphragm in here. There's a little button on the side that you pump up and down, just like this engine over here. Right here is the lift pump, and there's a little button you push up and down. There's a diaphragm in there that moves the fuel along. So, in between there, you should have a water separating fuel filter. The most common one is a Raycor water separating fuel filter. If you have an older gentleman, like this gentleman back here has got the Perkins, they have a 2-piece filter that's in there. It's a bear to change and it's a bear to bleed. A lot of times, some of your older Westerbeeks and Volvos were like that as well. But if you get the chance to upgrade, I would definitely upgrade to a Raycor type filter. Reason being, you can get them anywhere. And so if you're traveling and you need a fuel filter, then it's nice and easy for you to get one. It's not a bad idea to have it. Anyways, water separating fuel filter goes right there. Then your fuel comes down, goes through your lift pump, as I was saying. Then it goes to the final filter that is on the engine. This can be a canister type, like you'll see right here, or it can be one that's similar to this. A lot of engines have smaller ones like this. This one's the screw-on type. And after the fuel filter, it goes to your injection pump. So you have low pressure fuel from your tank, through your water separating fuel filter, through your lift pump, through your final fuel filter, to the injection pump. Usually on the injection pump, you'll see a bleeder valve at some point on here, and I'll discuss that a little bit further in a few minutes. Also on here, on this one right here, this is called a bleeder valve or a bleeder screw, okay? And then after this, it becomes high pressure. You go, remember back to the animation I had, it showed the fuel going in at a high pressure spray. And the reason behind that is because you've got that heat coming up, and liquid diesel itself won't really burn. The flash point is pretty high on it compared to gasoline. So it has to go in at a high pressure atomization just prior to top dead center on that piston to cause the explosion. When that doesn't happen, you'll hear diesel sometimes, say you've been trying to start it and you can't get it to start, you've just been dumping fuel in there, you hear that really loud knock sometimes. That knock comes from liquid fuel in the cylinder. Cylinder's designed to have pressure in it and pressurization, not liquid. So, after this, it then goes to your pistons, and that's when it shoots in as an atomization of fuel. These fuel filters, this one and this one that you can't see, but I told you about, I recommend you change them annually or every 100 hours. Preferably in the fall is when we would change the filters. Reason being is so your fuel, your diesel fuel, not only does it make your engine run, but it lubricates all the vital parts, mostly in here and in here. This is a rubber diaphragm, so it doesn't really need a lot of lubricating. However, it does lubricate things as well. So if we do them in the fall, before we lay the boat up for several months at a time, now you have the peace of mind of knowing that your boat is put away and your engine is preserved to last through the winter for the months that it's not being used, with good clean fuel in there. Biggest problems we run across is, let me back up. And then show me by a show of hands, I bet there's a lot of you. I get this question all the time, but how many people wonder, should I leave my tank full or should I leave it empty? A lot of people think it should be full, a lot of people think it should be empty. This is my experience. I would say 7/8 of the way full is a good place for it to be. Reason being, and keep in mind this is a small looking tank, but in your boat they're much bigger. 7/8 of the way full, because any less than that, usually you have a metal tank, and in the Great Lakes here, and in our area, it gets cold, it gets warm, it gets cold, it gets warm, which is going to cause condensation, which is eventually going to lead to algae buildup in your tank if the fuel is not treated properly. I used to say keep it full, and then about 8 or 9 years ago, I started discovering that's not a good idea. Because in the spring, when it starts warming up, usually when people bring their boats in, it's in the fall, it's a little bit cooler. And so in the spring, when the boat starts warming up and coming back to temperature and the air is getting warmer out, I've discovered that if it's all the way full, it'll end up going through your vent line and usually running down the side of your boat, and it makes a big mess, especially if you're shrink wrapped, because it usually puddles up inside the shrink wrap. So that's why I recommend 7/8 of the way full. Yes, Barry?
Gasoline evaporates and gets cold. Does anything happen to diesel fuel?
Okay, he asked that gasoline evaporates and cools. Does anything happen to diesel fuel? If treated properly with an algicide and a cetane booster, which most of your marinas that you go to include a cetane booster in the diesel fuel that they sell, then there's not a lot of separation that happens like the fuel does. It doesn't have the alcohol in it like the fuel does. Gasoline does, rather. But, as I was saying with the condensation, that does happen, quite often. So, yes.
Is there any particular fuel treatment you recommend?
Okay, is there any particular fuel treatment that I recommend? I recommend that we sell it up in our store. Unfortunately, and this is just the unfortunate part, it doesn't come in small doses. It treats a lot of fuel. It doesn't ever go bad, but it's a big thing. But ValveTech, I've always used the ValveTech product because it has, so when we start talking about diesel additives, there are diesel additives that include the cetane booster, the water prevention, the stabilizer for the fuel. But ValveTech covers it all. It has it all in there. It's all one treatment. So that's what I recommend. We have, or if you weren't going to go that way and you want to go with the smaller, the Startron stuff actually works pretty good, but the Startron is a stabilizer, and then there's also right next to it up there, we sell a water treatment. It's basically a very small amount that goes into the tank that will eliminate any water, which would mean condensation would be absorbed as well so that it doesn't get into the filter. How do I know I got water in my tank? Well, that water separating fuel filter, whether you're doing it yourself or Larson Marine's doing it, they will normally call you and say, we found a lot of algae, and by algae I mean just that. It looks like slime. In your fuel filter, in your water separating fuel filter, the normal thing to do is to go to the tank, the sending unit, remove the sending unit. We don't have one on here, but it would be like on the top of the tank. Sending unit meaning what tells you your level. Even if you just have it on your tank, we can still remove that. Go to the very bottom of the tank and take a sample and see if there's water in there. I would say probably 40% of the time we find water, which we can't see the inside of the tank, so then we only can assume that along with water and the algae that we pull out, that the rest of the tank is like that. So that being said, the other times, the filter that's there has simply done its job. There was some moisture there, could have been from condensation, could have been from someplace you picked up fuel, and the filter simply did its job. I mean, it doesn't mean it's a bad thing if you find algae and dirt and stuff in your filter. It just means that your filter did what it's designed to do. Okay? Yes, sir.
On motor-side boats, sailboats, do they have bathrooms in them, like my Catalina?
Yes. Okay, the question was on a lot of boats, do the tanks have baffles in them? Yes, the answer is yes. They do have baffles in them to stop the fuel from sloshing around. And if that's the case, as far as, I'll get into cleaning in a minute and then I'll describe that a little more. It's probably where you're heading with that. Okay, so now, if we're changing our fuel filter on a regular basis, for those of you with the smaller diesel, any of the diesels actually, we take our fuel filter off. A good practice to do, especially in a boat, because at the engine manufacturing plant, they have these engines right in front of you like this. And wouldn't we all love to work on our engine like this rather than in a boat? Okay? So, sometimes hard to reach. A lot of the manufacturers, including Yanmar, has kind of tried putting all of the service stuff on one side to make it a little bit easier. But then the boat builder goes and puts the engine in first and then builds the rest of the boat around it. And it's next to impossible to reach stuff sometimes. So what I do is I take baggies with me when I'm doing service, and I put rags inside, and I get the filter loosened up, and then I'll put the baggie around it, and I'll continue spinning it like this to loosen it up. That way I'm not making a big mess inside my boat, because nobody wants that diesel smell that's next to impossible to get out. So you can unthread it like this, and then this will catch anything, and the rags will help catch it. And sometimes this is hard to reach, And get it back on there so I don't have a big mess up here. Sometimes this is hard to reach. You can even, the baggies are usually strong enough if you get a decent one, and this is just regular Ziploc, man, that you can drop that. It'll fall right in there, and then you just hang onto the bag. And then it's not dropping and rolling under the engine and getting in the tray beneath you. Okay? Then you take this fuel filter, you fill it back up with clean diesel, and you screw it back on. This eliminates or helps reduce the amount of air that's gotten into your system, because your diesel engine fuel system needs to be basically a continuous line, if you will. You have a line, or you write on a piece of paper, you have a continuous line, that's a fuel system on a diesel. You put a line and a dash, or like spaces between it, like a bunch of dashes, and you have air in between there. When that air gets through the injection pump, it's going to cause your engine to stall. This happens a lot. We have a lot of people that will change their own filters, but they don't bother filling this up, or the Racor, the first filter, you fill that up as much as possible. And then you go to the bleeder screw. On this one, it would be here. Sometimes you'll have one at the injection pump. As I said, it's all low pressure at this point. It's all from the lift pump, which is on this engine located right here. Okay? So this hose comes up, it goes into the filter, it goes out of the filter right here, and goes down to the lift pump, this being, or the pressure pump rather, this being the pressure pump on this one. So if you're gonna bleed the air out of your fuel system, the furthest you can do it without turning that engine over would either be a screw like this at the injection pump or the one on top of the filter. Usually the one on top of the filter is perfectly fine because you have not injected any air into the rest of the system, because you've not taken anything off downstream from right here. So you put your filters on, you break the bleeder screw loose. Once again, you take a handful of rags, just because you don't want a big mess, you put them around the filter, depending on where your filter's at, and then you pump the little hand pump like this, and it'll suck the fuel through, and you'll get air bubbles. Once the air bubbles are gone and you've got solid fuel, you've gotten the air out of that fuel system. When you're done, start your engine. Usually, after this, I'll put it up to, not on the power boats because they're a little differently designed, but on the smaller diesels, I'll put it up to full power just to start the engine, and then I slowly bring it back down. And the reason I slowly bring it back down, if there's any air left in that system, if you're asking for more fuel, it'll help push it through a little bit easier. But here's a very, very common occurrence. It's happened here, in my 20 years I've been here, I bet you it's happened probably 700 times. Somebody will change their fuel filters in the fall. They won't run their engine after they're done. They start their engine in the spring. Your diesel's gonna run until it hits that air bubble. I can tell you from experience, it's usually right around the corner as you're heading towards the lake from Larson Marine. Happens a lot, and we've towed several people back, and we've had people sail back in because it happens in their busiest time when we can't come tow you in. Not that we offer towing services, but usually if you do have a problem and you're still in the channel, we will try to help you the best we can. So once you've changed your fuel filters, then you should definitely run your engine at the dock, preferably in gear, because that'll get it heated up to normal temperature. Tied up good, of course. And just run it in gear for 15 to 20 minutes. If everything's fine, everything's fine. If it does start to die off a little bit, push your throttle up. That will usually cause the air to go past and work fine. However, say you're out on the lake and you heel over, and baffles like you were talking about are supposed to keep the fuel, baffles are basically plates inside the tank to keep the fuel from sloshing around so much. But sometimes it will happen, or if you're low, or if you have a lot of stuff on your tank. This has happened. I've talked several people in off of Lake Michigan who have called me and said, my engine runs for a while, then it slows down, it almost dies, and then it runs good for a while. And usually what's happening is you get dirt in the bottom of the tank, the suction goes to the bottom of the tank. You get out there in a choppy sea, you've got stuff in your tank, it starts moving around. That's usually the cause of that. However, if you're one of them people that forgot to check your fuel level and you run out of fuel out on the lake, and you're changing your filters, that's why I'm telling you now and recommending, I keep over next to my toolbox in the shop, I keep a gallon jug. It used to be oil. I've got big paint written on it, or big paint pen says diesel fuel. Okay, and I keep that with me as a spare, and I suggest you keep some. If you're the type of person who does a lot of your own maintenance or you're concerned about this, make sure you carry a little extra diesel with you. Okay, so now you fill your filters, but you've completely run your engine out of fuel, which means from the injection pump here through these injector lines that are on here, also noted right here, and into this injector, you now have air in there. And to get rid of the air, remember earlier I said that's as far as you can push it with a lift pump. Now you have to be turning your engine over because you have injectors, which are here on this engine, and I can go over it with you one by one if you want at a different point. However, these lines right here that go into the injectors, you have to break those all loose, okay? A majority of engines, including the bigger powerboat engines, I would say on 95% of them, it's a number 17 metric wrench that fits those injectors. Okay, if not, it's an 11/16 if it's standard. I take my same rags, I put them in right here, and you'll be able to see it a little bit, but this is just around the injectors, okay? I have them broke loose now. I need to turn my engine over so that I can get the air out of those lines, because the only way this injection pump is going to run is if the engine's turning over, because it usually runs off of either an idler gear or a lobe off of the cam, okay? So, in your automobile, you have an exhaust, a tailpipe that runs, out the back. On your car, or on your boat rather, we have a hose that runs out there. We have to suck water, the raw water that's underneath the boat, through an impeller, which we'll get into all that in a few minutes, through the engine, through a heat exchanger, and then out the exhaust and out the back of your boat. That's the reason every time you start your engine, you make sure you have water going out there, because if you don't, you have nothing to keep that hose that runs through your boat cool, and you've got really high exhaust temperatures, up to 3,000 degrees going out through a rubber hose. The only way to keep that cool is with the water, which we'll get into further. The point behind me telling you this is, so you have your raw water pump on this one. I can't really show you out here, another poor design, because this one, when you're in an enclosure in a boat, you have to take the alternator off to get to. Anyways, you've got a seacock that comes down and allows water to come in there. If you're going to bleed the injectors themselves, you need to close that seacock. The reason you're going to close that seacock is because you will now be turning the engine over and sucking water in. If you have no power from the engine running to push that exhaust out through the whole length of the boat, that water is going to take the least path of resistance, and it can come backwards and go into your exhaust valves as they open. Next thing you know, your engine won't turn over at all, because your cylinders are now full of liquid. And remember, I told you your diesel is designed to compress air or make compression in the cylinders and not liquid. It'll completely come locked up. It won't even turn over at all. So anyways, you close your seacock, you turn your engine over by hand, you have your injectors broke loose right here. Turn it over in a short blast of about 30 seconds. You don't want to just continuously run it until you get fuel out, because now you're throwing 12 volts at a starter that has wires on it that's going to heat up, and you don't want to burn anything up, okay? If you're single-handedly doing it, there's one of two ways to do it. You can put the rags in here, you can come back up and check them occasionally, or a lot of us have made up starter buttons that we will hook on the start solenoid, and so we hook one to power and one to start solenoid, and we press a button to make the engine turn over so we can physically see what's coming out of here. You want all the injecting lines loose. If you're by yourself and you have to do this, then you go down, you pull the rag out. If it's saturated completely, where these injectors were, then you know you have fuel coming out. You do not stop until all of them are bled at the same time. It's not like your brakes on your car, and I've had technicians that have come from the marine or from the auto industry to the marine industry, and I hate to explain to them, you have to make sure everything stays open until each one of those rags are saturated. Then you have all the air out. Then you tighten them all back up, and you go up, and you start your engine, as I said a few minutes ago. For the ones that have electric fuel pumps, when you're doing your priming, a lot of times with the electric fuel pump, you don't have to open a bleeder valve because usually the line that comes off of here, that on this one is a bleeder, goes back to the intake. So it'll circle back around and go back to the intake. So the electric pumps, a lot of people say I have a self-bleeding engine. Well, it's not self-bleeding, it's just the way it's designed, it will self-bleed itself. So, yes?
When you crack those 3 lines, will the engine start?
Good question. When you crack those 3 lines, will the engine start? No, it will not, because it is losing compression through those cylinders. So, the injector right here that is seated in the head, let me go back a couple and I'll show you. So that injector that's right here, well, it says compressed air, but it's compression. The injector that's right here, instead of this creating heat and compression, or making the compression that makes the heat, it's now escaping, so it's not going to start up. That's the reason I tell you to do all of them. If you only undo one of them at a time, there's a chance it could start and it would run like crap, but it would really make a mess. That's why we undo all 4 of them, or all 3 of them, or however many you have.
And the other question was, you talked about the C-top over here. Is that the one that goes through the hull?
Yes, and I'll get into that when I get into the water system, but yes, that is. Usually a ball valve, could be a gate valve. It's going to be downline of a strainer that you should have. Like I said, I'll discuss that in a few minutes. I'm just giving you an idea. Usually closed. When it's in line, it's open. You can see through it.
So when you close that valve, you start turning it over, that's not going to screw up the water pump?
Okay. The question is, so when I close that valve and start turning it over, that won't mess up the impeller that's in there? No, it won't, because we're not going at a super high speed, and it usually doesn't take more than 3 or 4 times of cranking it over to get the air out of that. If you look at how small those injector lines are, you're really not, you know you have good fuel all the way up to there. It doesn't take long to push the air out. Yes, sir.
Mark, what is the condition, one more time, you mentioned this, where the air bubble you're trying to mute out of your injectors gets past the fuel pump? What is the condition where the air would accumulate, that little bubble that's being
Okay,
between the fuel pump and the injector?
Okay, so he's asking what's the condition that would cause the air in the fuel line, as I was discussing. Usually the only time that's going to happen is 1, when you're doing the maintenance, if you don't fill the filters and bleed it all the way to the furthest point of where you removed it. And the other one is when you're going to run out of fuel. Okay, so I can have fuel come in and it goes into my lift pump from my tank, into my lift pump, up to here, and in here. And so, in other words, if I were to take this filter off completely, I still haven't interrupted the fuel in this line, through these, in the injection pump and through this. I could take the filter completely off and the diesel engine would still start. And it would run because, remember we had low side and high side, or low pressure and high pressure? Anything opposite the low pressure side, the high pressure side is still full of fuel and is still making pressure in the injection pump and coming here. So it would run, obviously, until it was out of there, and then you would hit an air bubble. maybe that better explains how you would get an air bubble in there or air in your line.
Most common way is if you don't top off the fuel in the fuel filter where you put it into the replacement.
Yes, he said, so the most common way, is what he was asking, and the most common way is if you don't fill your fuel filters prior to, actually, that's not true. The most common way is if you don't bleed your low pressure side before you start your engine. That's the most common way. And the purpose being, unfortunately, hate to pick on you, but Perkins engines, having the two-piece filter, you can't fill it with fuel. It'll run right through onto your hand. So you have to put that in, and then you have to use the low pressure pump and pump it until all of the air is out of the system. So the most common way, the best way to answer that is, most common way is if the engine, the low pressure side is not properly bled prior to attempting to start the engine, after maintenance. Yes.
Yeah, two questions for you, Mark. So, last week's class, you talked about PMS and the CPAC valve. So the raw water CPAC going into before the diesel, would we have to remove that to be able to PMS both sides?
Okay.
Put it back in?
Yeah, he was asking last week, in my seminar, I talked about preventive maintenance through a ball valve and lubricating it. You don't need to lubricate from both sides. Lots of times if there's a strainer on the bottom of the boat, that's difficult. But usually where the raw water pump is, the hose to get to is fairly easy, especially if Larson Marine is winterizing your boat or you winterize your boat as Larson Marine does. So last week when I talked about this, I said it was easier to walk around the bottom of your boat, close this halfway, shoot some lubricant in there, and then go up and cycle the valve a couple times and then open it back up. Because getting the hoses off from the inside is a very difficult thing, especially something that's been clamped for several years. However, this would be an exception to the rule. When we winterize boats, especially sailboats, we winterize all our sailboats in the water, and then Doug tows them to the travel lift and hauls them out. And so when we do this, we remove your hose off of your seacock for your engine, and we hook our antifreeze buckets up to that, which I think 2 weeks from now I'm doing a winterizing and commissioning seminar. I'll explain it a little bit more in that as well. But that would be the one exception. That hose should come off because we take it off and put it on at a regular basis.
And my second question is, everything that you're talking for pre-check for the diesel, that should be on the technician's diesel section?
Yes, he's asking everything I'm talking about should be on the tech sheet. Well, on our winterizing orders or our summarizing orders, our form stack that we use, it gives you the option to change fuel filters. And the technicians have all been trained just as I'm training you guys right now as to what to do. Arturis and Matt that work with us, actually, and Larry, all three of our technicians that we currently have all been to the Yanmar school, not to the extent that I have with the master training tech and stuff, but they've all been to the schools and they all know that that's the proper way to do it. Yeah.
Is there is it just a generic plumbing silicone that you use on the valves to lubricate?
Okay, he's asking, is there a generic or is there something you would use on the valves? I mentioned this last week as well. Anybody here last week, remember what I said? Usually a white lithium grease or oil. And the reason I go with the lithium is simply because it helps repel the water way better than a regular grease does. Okay, a lot of greases will get washed away. So I'm sure you might find something that's better. For plastic valves such as Barry has in his boat, you would use Marlube. It's called Marlube. They actually have a lubricant you can use on it. Not only, as he had mentioned about lubricating these, a lot of them, like this particular one I have, has a piece that unscrews right here. So with that kind, you can remove that, insert a Zerk fitting and use a standard grease gun and put some grease in there and just make sure you cycle it back and forth. Preventive maintenance, it doesn't cost, it pays. You need to remember that, because this valve, as I've said, not just for your engine but other things, is usually in a place that you need to bend your elbow 3 directions to get to. And if somewhere between, been there, huh? Somewhere between here and where this hose is leading to, gets a water break in it, and you now have water coming in from the lake or the ocean or wherever you're at into your boat. You need to be able to close this valve. So annually, you should make sure you're cycling these and checking them. But anyways, back to the fuel system. Any other questions on fuel? Yes.
Additive, that you put in the diesel tank, and that same thing work for gasoline engines?
Okay, he asked the additive that I put in the tank for diesels, will it safely work for gas engines? No. It specifically says on there for diesel. There are additives for gas as well. Valtech makes one for them as well. In fact, the fuel that we sell out here, I just got a load of fuel this week, and I had to put, we actually have a big 5-gallon jug of it, and the dilution is insane. I mean, it doesn't take much to protect the fuel, but we put it in our fuel, and most of the places will sell it, but it specifically will say gas or diesel. Make sure you're paying attention to where you're getting fuel. Say you're out on the lake and you're cruising around, and you notice you're getting low on fuel. Try to go to a place that you see other boaters coming and going from. I've had a lot of people that have taken trips to the North Channel over the summer, and they come up and come back and their tanks are horrible. You definitely want to go to a place that's reputable and has a lot of people going in and out of it. That means they're selling a lot of fuel. Just like water can get into your fuel tank on your boat, water can get into a fuel tank that's either above ground or below ground as well. So if somebody's not, if somebody is not treating their tanks or selling a lot of fuel or moving a lot of fuel through there, you could be the unlucky person that fills up with the crap that's sitting in the bottom of their tank. So just keep that in mind. Yes, sir.
How important is polishing fuel?
Thank you. That was the next place I was going.
Fuel from a pretty good place all the time, you really have to be.
Excuse me. His question was, how important is polishing fuel? And some people are probably thinking, polishing fuel? My wife polishes, or I polish at home, but what are you talking about? Polishing fuel means the fuel that you have in your tank gets run through a filtration system and then a water separating system and put back into the tank. But prior to doing that, like we have a product called Pri-D, you put in the fuel, and what that does is it breaks up any water or any algae or any sludge that's in your tank. It's, as we're running it through a minimum of 7 times through our polishing machine, everything will get trapped in the strainer. We'll empty the strainer several times during a fuel polish, and any water that's in the fuel will get run through the filtration system. So we're basically polishing the fuel. Something to keep in mind when we polish the fuel, we don't just want to circulate the fuel through there, okay? A lot of people will say, well, if I got dirt in my fuel, just empty it and put it back in my tank. The inside of the tank is still dirty. The fuel, the algae that's happening there, the water, it's all clinging to the inside of the tank. That's the reason we use this additive. When we cycle it through, it kind of washes the sides as well. A lot of times, if we do a fuel polish in the water, we'll want to leave the catalyst that we put in there, sit in there for a couple of days, move the boat around just to slosh it around a little bit. So as far as how important is it, if you have dirt, if you have debris, if you take a sample off of the bottom of your tank and you find this, then it's definitely recommended. But fuel polishing is not a service that I have ever done, or that I know of. This gentleman, Roy Cohen, down in Michigan City, who has a bigger polishing machine. Roy doesn't neither do it as a regular preventive maintenance thing. He only does it as a corrective action when you have an issue. Yes, sir.
When we run our engines at high idle, aren't we providing more fuel to these, to the pumps and the engine actually uses, and it's going through the filters, and aren't we really polishing our fuel at that point?
Okay. In a sense, he said, when we're running our engines at higher RPMs, and so we're forcing more fuel through and it's going through the filters, isn't that polishing? In a sense, yes, it is. However, The strainer, the water separating filter, which is more like a strainer type of filter, and the final fuel filter can become clogged. And once it becomes clogged, then you have those issues. It is cleaning it, and so on a gas engine, when you press your accelerator down on your car and you take off, all of the gas that it's saying give me so I can produce this horsepower goes through it. On a diesel engine, only the amount of fuel needed for the RPMs you're going goes through your injectors. The rest returns to the tank. So you're not always using all of the fuel that it's asking for like on an automobile. So yes, it is in effect polishing it, but not to the extent of if you have something in your fuel tank that needs to be polished. Because like my fuel polishing machine I have in the shop, the water separating filter that you have on your boat, you can't see through that. The strainers I have, you can. So as it continues to get the algae and the dirt, then we empty it and we continue going until it's completely clean. And then we remove that strainer and we put a water separating filter in there and we run it at least 3 passes, and there's a gauge on top of it that'll tell you when the water filter gets full with water as well.
But then again, that's corrective action.
That's corrective instead of preventive, correct. Yes? Okay, he said metal tank or a plastic tank, vice versa. I don't really have a preference. I will tell you this, boat builders will use whatever they can get the best deal on a lot of times. Okay? And the reason I say that is because you will see, say Westerbeek did this, or not Westerbeek, Catalina did this a few years back. They were going with Perkins engines for a while, then they went to Yanmar engines, and it was just a matter of they were getting a good deal from this engine manufacturer, so that's what they put in for a while. Then they were getting a better deal from these guys, so that's what they started putting in their boats for a while. It's just kind of like a supply and demand thing. As far as for diesel, a plastic or a polyethylene tank is actually what it would be. I myself would probably rather prefer that over a steel tank or a metal tank, simply for what we discussed earlier, condensation. You're not going to get as much condensation on plastic because the heat transfer is different than it is on metal. Yes, sir.
In the Navy, we have a way of doing fuel samples. So what's the best way to do it in space type?
Okay. Sit in the Navy, thanks for your service. We would do, they could do fuel samples. What's the best way to do it here? We could send the fuel off if you wanted an in-depth analysis. We could send it off. We use a place in Wisconsin called Huxdorf Diesel. But the best way is, like I said, I pull a sample from the very bottom of the tank. I'll usually put it in a baby food jar and leave it sit for at least 6 hours. I can see if there's any water separation because fuel is lighter than water and it'll float on the top. Also, sediment is heavier, so I can look at the bottom of the jar and see. So we basically just do a visualization. If we suspect there's a problem with the fuel injection system or the injector, or it's not atomizing as it's supposed to be, we then send it off. And as I said, this comes out of here at a high pressure atomization. So we will send it off to Huxdorf, and what they do is pop test it, basically. I have the equipment here for an old Detroit diesel because if any of you have a Detroit in your boats, and it's 671 or 471, 371, whatever it is, it doesn't have an injection pump like this. It's all done through the injector and has what's called a unit injector. Anyways, so we send it off, and they basically shoot pressure through here, and they have gauges on there, and they can see at what pressure that pops open to shoot the atomization into the cylinder. And they'll often tell us that everything's normal, or you got a leaky injector tip and you need some new parts, or whatever it is. Usually indicated by, and I know you've all seen it, you're following somebody in the harbor, you're like, man, what's that black crap all over the back of their boat? Well, that's all unburned diesel fuel that has basically come out the exhaust because it gets so hot and comes up. But that's what you do. Good questions, folks. Thank you. Yes, sir. Okay, the question is are you saying if you don't use it a lot? Right. I would keep the tank, as I said earlier, at about 7/8 of the way full. You can top it off if you know you're getting ready to go on a trip and you're gonna use it a lot. But I definitely wouldn't let it get below a quarter of the tank. Although we have the baffles like you and I discussed earlier, you still can, if you start getting low or you get into, anybody that's been out here knows Lake Michigan can be very unforgiving and a storm can come up really quick. And if you get in really high seas and you've got your sails up, and you start tipping, leaning back and forth, heeling over. Funny story, I was sailing with some friends last summer. My wife's not very familiar with sailing, and so she said, so every time we keeled over, so she had a good thought, the keel gets you to do the right, anyways. So when you start heeling over, then you don't want to start sucking air. The other thing that rears its ugly head when you do let it get usually below a quarter of a tank is if there's any dirt in that tank, that will usually start getting sucked up the intake. I mentioned earlier, I've taught so many people back off of the lake, and it's usually when it does become, so this is on the outside, but imagine if this was on the inside. This pickup valve that goes, actually it's down here rather, that's the vent. The pickup comes down, it doesn't go all the way to the bottom of the tank. This is the bottom of the tank, it's usually up like this, about a half an inch, cut at an angle. But if you get enough stuff and you get your tank low enough, everything's gonna go towards where that suction line is, and that's where it's gonna pile up. So what I've actually talked to a lot of people through is, you may have stuff in your tank, what I need you to do is take your fuel line off, blow backwards through it, and it should blow pretty freely. And then, excuse me, then you have to bleed through your filters because you now put air in there. But to blow backwards through that, and if it's got some hesitation or then it breaks loose, what's happening is you're running your engine, the fuel's coming up through here, you start getting a restriction in the bottom, you're not getting the amount of fuel that your engine's asking for, so the idle starts coming down. You pull your idle back down, the engine seems to be idling perfectly fine. This tube is no longer demanding such a suction on the fuel. Whatever was in there comes back out and kind of settles itself in the tank. Then you take off again and it's working perfectly fine for a few minutes. Then it starts idling down again. You've now sucked that tube back full of stuff. So I've talked to a lot of people through that. Something definitely you should watch out for. Okay. I got some other slides here. This just kind of tells about fuel injection. Sometimes I get ahead of myself and start talking about the stuff that's in the forward slide. Sorry, but I'll leave that there just so you can look at it for a minute. And as I said, if anybody would like my slideshow, I've got nothing to hide. To anybody, it's just a slideshow and it's information, but when you talk about it, it adds a little more. Speaking of, just like last week, my seminar is being filmed by our in-house photographer, Richard, today, and he will be displaying it on the website for 2 weeks. So if you missed something and you want to go back and look at it, you'll be able to view it. As I said, I get a hold of myself, so ahead of myself sometimes. Buy fuel at marinas that pump lots of fuel. Keep the tank and the full, which answers your question, and the filter cap tight, filler cap tight, and only use recommended additives as I was discussing with you. It'll stay right on it what you use. The filler cap, that's one other thing I want to mention. Pay particular attention. If it's difficult taking off, stop, clean it up with something. That means there's something in those threads. And here's what's going to happen. As soon as you take it off, it's going to fall down in there. Okay? So make sure you clean it up. There's an O-ring on there that seals it. Take a look at the O-ring occasionally. Make sure it's still resilient. What I mean is, you've all picked up a rubber band and you know how it stretches like you're going to shoot it at somebody. But then you've also picked up rubber bands that fall apart. Same thing with the O-ring. You want to make sure it's resilient. It wouldn't hurt once a year if you just put a little bit of oil on it. Don't take it and douse it with oil and stick it in the tank, but a little bit of oil doesn't hurt to stay on there. And when you tighten the cap, tighten it down until it stops. Don't tighten it like you're King Kong and you're trying to tighten a bottle cap, okay? Because what's going to happen is that O-ring will get in there and it'll get pinched, and the next thing you know, you won't be able to get your fuel cap off, okay? The O-ring's designed to make the seal, and quite honestly, if you tightened it hand tight with that O-ring, the O-ring would do its job and stop water from getting in there. But I like to say, go hand tight and then another quarter of a turn, that's plenty. And then this slide is, it's important that everybody knows how to evacuate the air from the system, bleeding. I do have a fuel bleeding seminar that I do. I don't believe I'm scheduled for it this year, but anybody that wants to contact me, I can certainly walk you through it. I've gone to boats, I've explained, even Mr. Richter back there last year before they took off for the season, I went on board his boat and gave him a little one-on-one on that. Didn't I?
And I took less of paint, put a little spot of paint on all the spots.
Okay, good idea. So I got no problem doing that if that's something you feel you need. My biggest thing is, having been around the water my entire life, I just want everybody to get back home safely, okay? The lake is very unforgiving. Your car breaks down, you can walk home and tell your wife you ran out of gas because you didn't look at your gauge, or your husband, or whoever. Your car breaks down, I don't think there's anybody in the room here, or your boat breaks down, rather, nobody can walk home and tell what happened, okay? So I just want everybody to be really safe out there. Your battery. At Larson Marine here in the wintertime, we disconnect the negative side of the batteries so that they don't discharge over the winter. I would say 99% of the batteries that we do that to are perfectly fine in the spring. The ones that aren't, we're due for a change anyhow. But before you put your boat away in the fall, if you have a lead acid type battery, you should make sure they are full of water, distilled water, and that they are fully charged before you disconnect them for the season. And we do the same if we are the ones doing your boat. Okay? Check your wires occasionally. You're checking for, just like your belt, you're checking for cracks. You want to make sure that the casing on the outside hasn't loosened up. When we disconnect the batteries, anything we disconnect, so you should really only have one cable on your positive and one cable on your negative, okay? A lot of people will have 40 items on there. That's a little exaggeration, but I've seen up to 8 or 9 items on there, okay? That's not good. When you start doing that, you're setting yourself up for fires and things not working properly, okay? That's the whole reason you have a battery switch, which on here it's not listed. You have a battery switch. You also have a fuse panel or a gauge panel, you know, down in your boat that things run through. Because all your other accessories should be fused. Well, yeah, but isn't it okay if I put a fuse between this one I'm running to? No, it's not designed to have that many things on the post. You're designed to have your normal battery post there and then run through a switch panel, okay? That's a big problem we have with a lot of people. Anyways, you're checking everything. You want to make sure the wires haven't broken down. You got to figure they get hot, they get cold. They're in an engine compartment now that's not like on your car when you're driving down the road and the air is flowing around your engine and your wires and things stay somewhat cool. You're now in an engine compartment that has insulation around it to keep the noise down, that keeps it even warmer in there. So it gets warm, then you shut the engine down and you don't come back for a week, so now it's cooled down. Like anything, expansion and contraction. And the same thing is going to happen in your engine compartment. So you should always be looking at your wires and making sure they're not brittle and not starting to break down. Yes, sir.
Is it okay to leave, your shore power on your battery to recharge it when you're not using the boat for 3 or 4 months?
Thank you. Okay, so the question was, is it okay to leave your battery charger on when you're not running your engine or when your boat's sitting for 3 or 4 months? I wouldn't do it and walk away from it. Your battery chargers nowadays are all built with regulators in them, or automatic chargers they call them, so that when your battery is full, it'll turn off. If something internally like that was to fail when you were away from it, then you could overcharge the battery so much that it cooks it sulfates, and it can explode or have fires. As far as during the season when you're in the water, yes, I definitely walk away and would leave it for, till you get back to the boat the next week or whatever. A lot of people do that. What you don't want to do, there's 2 things that I'm going to mention, is you don't want to have your engine running and your battery charger running at the same time. Then you're going to get backfeed on it, okay? You could either blow out your charger or you could blow out your alternator. The other thing I want to mention, very common problem, people have done this. And some people say, I've been doing that for years, and if you have, well, then you've just gotten lucky, because I can tell you I've seen it more times than not. When your diesel engine, or when your engine is running, do not turn off your key while the engine is still running. Leave your key on until you have shut down your engine. Because what happens when you do that, you're still sending a charging pulse, and if you turn the key off, the key is normally hooked up to the battery, because that's where it gets its power from. Now you will blow the diodes out of your alternator and it'll stop charging. I've seen it happen so many times. And I've also had several people tell me, I've been doing like that for years. And my only result is, you've been lucky, because I've seen it the other way way more times. Give me 1 second. Yes?
And so you're saying, don't have the engine and the battery charger running at the same time. So disconnect your shore power before we start the engine?
Or just turn off the battery charger. Okay, so yeah. The question was, so should you unplug before you start the engine? You don't have to unplug, because you might have other components you're still doing, like the air conditioner or something like that. So definitely make sure your battery charger is turned off. If your battery charger runs off of your boat being plugged in, you need to have an electrician come out and fix that, because it shouldn't be that way. Yes, sir.
What about using solar power?
Okay, his questions, what about using solar power? A lot of people have gone to that. And solar power is fine, but it's still, the solar is still putting a charge on the battery. So now so solar charging is, say it's charging at 20 amps. Standard diesel alternator on these small engines is 55 amps. So now you're sending 55 amps. I would definitely disconnect the solar charger, because I don't want to blow out those panels that I've installed. Yes, sir.
Something that, you mentioned about the charger. Does that go for the, charger is installed in the boat also?
That's, okay, you asked about the charger, is that the one in the boat? That's the one I'm referring to, is the charger that is installed on your boat.
So we need to disconnect that?
You need to turn that off
When you go out.
prior to starting, yes. Yeah. When you're out on the lake, if it's turned on, it's not gonna do nothing, because you don't have shore power coming in, unless, of course, you have a generator and you're running a generator. Then you should have the battery charger turned off. You shouldn't be running your engine and your battery charger at the same time. Okay? Pretty simple, like I said, components. Gauge panel runs off of that as well. I'm going to talk about the lubrication system, our oil. You want to keep your oil clean, and you want to keep it full. You can see the difference on those two. Now, people will ask me, they check their oil. You check your oil on a cold engine, you pull the dipstick off, you wipe it off, you stick it back in. Oh, sorry, Richard. pull it out, we wipe it off, we put it back in. A lot of them are like this. You see this little rubber piece here that keeps anything from blowing back out? If you pull it out, you wipe it off, you put it in, you pull it right back out, you're going to get a false reading. Reason being is because this rubber has just caused a slight air bubble that can get in your dipstick and go down. And if you yank it and pull it right back out, there's a good chance you're going to think your oil is low and it's not. So you put it in, you wait a few seconds, and then you pull it back out, and then you check your oil. Okay? Usually you have a full mark and a low mark. Anything in between there is perfectly fine. You don't have to, if you're somewhere in this area, you don't have to just run out and get oil right away. That is a safe operating level. Okay? You start getting below it, then you start having problems, especially, once again, we get out here, we start heeling over, the boat starts going from side to side. Okay? That's a very important thing. A lot of people don't realize it. Then some people will say, well, my engine has this thing that unscrews on the top of the engine right here, right? And then I got another one right down here. Which one do I use? A lot of the engine manufacturers are giving you multiple places to use based on how your boat builder places this engine in the boat. Sometimes you can get to the top of the engine. Sometimes it's very difficult to get to the top of the engine. So it just gives you an extra source of where you can add oil to your engine. There's O-rings on those as well for sealing. Make sure when you take them off, the O-ring comes with it, and you clean it and wipe it, and before you put it back on, you put a thin coat of oil on it. A lot of times, the O-ring will get stuck right here. Be careful that doesn't happen, and if it does, I would usually take a small rag, put in here, not all the way, obviously don't let it go all the way through, but I would put a little rag like that and then pull the O-ring out, because you don't want that O-ring dropping in there. The only way you're going to get that out of there is by taking the oil pan off. And the only way you're going to get that oil pan off is by pulling the engine out of your boat or lifting it up in the boat. Okay? So be very careful of that. Oil, just like fuel filters, I recommend once a year, once every 100 hours. Engine oil only. If it's transmission, every 200 hours or every 2 years. Reason being, your transmission doesn't come in contact with all the carbon and the buildup that can happen from a diesel engine and the oil as much as your normal engine would. So, oil, I really like this slide here. Lube oil doesn't just make parts slippery. There's several things it does. The lubrication, but it does cooling as well. And then you got this hot oil that's moving around all the components of the engine. And then it goes through a cooler, through heat transfer. It's going to allow all those vital parts of your engine to get cooled as well. It cleans any, even though you've got the rings and they're designed of a material that doesn't just, you rub two sticks together, you see how eventually they start getting raw on the sides you're rubbing together. Same thing's happening with the moving components in your engine. So eventually you're going to lose some of the material, obviously not at a rate that is going to cause a problem, but so you do have that. The other thing is some of your components, your bearings on your camshaft, your crankshaft, there's actually a very small oil film that's between those. So they don't necessarily come up. I mean, minuscule, minute. But it does cause a surface between it. Basically a cushion between the moving parts. So this tells you how the oil in the pan is pumped. It's pumped through the intake filter and the piping. Tells you which way it flows, and then goes into the main galley, goes to the crankshaft journals and the pins. So I'll leave that there for just a second. You can look at that. So our oil is going to go through it. Eventually, after it's gone through all of these moving components that you saw in that animation that I showed you in the beginning. All that oil has lubricated, created cushions, and absorbed the heat. So then it'll go through your cooler and go back to your sump. So this basically shows you all of the things that it lubricates, and it all starts in the pump. I think I've left my pointer over there. It all starts in the pump. You basically have a pickup that goes down into your sump. That's the reason some of your engines, you see how they sit in your boat. Some of them are sitting back like that, some are sitting like this. It depends. You know, there's a lot that goes into somebody designing how an engine goes in a boat, and where your oil levels and stuff are going to be. So anyways, there's a suction that comes through here, through your pump, goes through your filter. Once again, your filter, just like your oil filter, I do the same thing. I take a baggie. I've taken other things. I've actually taken small plastic bowls, several different things. This one's even more difficult because the majority of your oil filters are on the side of the engine. And it usually runs down and it's a pain. So I'll get this under there the best I can, and I'll catch it and put it in there. A lot of times what I've done in the past, both with this type of oil filter and this type of fuel filter, is I will take the box that it came in. If I'm out servicing your boat, I'll take the box that it came in, and I will take 2 rags, and I usually take one rag and put it like this, and then the other one like this, and I have it sitting there. I'll get the filter out, and you know, it'll drop into here or whatever. I then take the new filter out of the box. I set this across the opening for the box. I then take the filter and set it right down into the box. This wraps around the filter as it goes in, doesn't make a mess on your boat, and I'm able to clean up pretty easily that I could go to dispose of the filters. Yes?
On our PMS cars, you're going to differentiate between lint-free rags and shop rags. So is there a difference in our engines whether we use lint-free or shop rags?
Okay, he's asking if there's a difference in our engines whether we use lint-free or regular shop rags. For anything that's on the external, for what I'm doing here, regular shop rags would be perfectly fine because I'm not introducing the rag to any of the internal parts of the engine. So I would just go with regular rags would be fine. A good oil absorbent rags. These are shop towels that we use. I have found you can get them at Home Depot, any of your box stores, but they have the box of rags that come. They're like blue cloth rags. Those work really well. They absorb very well. You have to be careful. So some people have lint-free rags, as you were discussing, that are usually made more out of a polyester than a cotton, and those do not absorb. You want to use something when you're changing your filters that's going to be absorbent, so that obviously it doesn't get on your boat and make a big mess. Nobody wants that. Make sure you pay particular attention. If you did drop some oil, the oil on a lot of the floorboards in these boats becomes like ice outside in the wintertime. It's very slippery. So exercise extreme caution. Okay? So then we come through our filter, and the oil goes past. Usually you'll have an oil pressure switch on a lot of your bigger boats and a lot of your newer boats. You have a switch and a sensor. Okay? The switch will sound an alarm if you get low oil pressure. The sensor will read the pressure for you and display it on a gauge. A lot of the older ones, electronics weren't as far advanced as they are now, and a lot of them were just regular old mechanical engines. Okay? This oil filter, when you're changing it, the one at Napa might be $4 cheaper, but my recommendation is you use the one that's designed by the engine manufacturer. The reason being, there's a check valve inside this filter. If it were to become clogged at a certain designed pressure, that check valve would open and allow oil still to get to all the major components of that engine so that it doesn't stop getting lubricated and seized up. That's my recommendation. If you say, well, I've been using it, I'm gonna continue to use it, that's fine. However, if you are under warranty and you submit a claim to Yanmar because it stops pumping oil, the first thing they're gonna say is, what oil filter did you have on it? And if you didn't have their oil filter on it, you're calling Mark, and I'm quoting you $20,000 to $25,000 for a new engine. Just not worth it to save a few bucks. Do the simple recommendation, please. That's a whole different story. You don't want me to get started, mister. Yes.
There was, an analysis on the, internet where they took different filters, there was, diesel engines with both. And they, cut them up, different brands, and compared them, and they're not all the same. The valve opens at different pressures, and so it's really important.
Yeah, exactly what this gentleman was mentioning, exactly what I just said. He said he watched something on the internet where they cut open several filters and they were all different and they lifted at different pressures, and how important it is on what I just said there, because yeah, if you get a chance to look at something like that. The other thing I want to mention about oil is, because this question is going to come up from one of you, oil analysis. And basically what that is there's labs, there's companies that we use, that we can take a sample of the oil as we're changing it. We can send it off to the lab, and they can tell, it's basically a way for them to monitor the internal parts of your engine that you cannot see based on the information in front of them. So they will check it for acid content, from metals rubbing together. They'll check it for water content. They'll check the lubricity of it, make sure that the parameters are where they need to be. They check it for several different things. And so if you haven't had one and it's something you want to do, you get your initial one, and then they will keep track, or you can keep track, and they send you a report that shows everything. And then over the years, you can continue to look at this and determine what's happening inside that engine, because obviously there's not a window for us to look in and see how much those things are starting to wear. So it's just another source that they've come up with that you can monitor your engine with. Yes.
On the type of diesel oil, 10W or whatever the running system is follow the manufacturer recommendation? Or?
Okay, yeah, they're asking if you should follow the recommended manufacturer's recommendations for oils. Yes, you definitely should. It's in your tech manual. It'll tell you. Once again, like I was talking about last week, a lot of stuff in your manual is going to refer to stuff for boats that are in the water 24/7 and all year round. That's the reason some of the practices I'm telling you here today might be a little different, simply because we take our boats out of the water, we put them back in. And so that's why I let you know that. But I'm glad you mentioned that. So, for your engine oils, you want to use whatever's recommended, okay? On your transmission oils, usually on the back of the transmission, it'll tell you what kind of oil to use. But if you're big like me, you're not always going to be able to get in there and see that, okay? Here's a very simple way to do it. For your transmission, if you pull your dipstick out, you wipe it off, and it's red, it's transmission fluid. If you pull it off and wipe it off, and it's the brown color, that's usually the oil that's used in your engine, okay? If you have a sail drive like this, and you pull the oil out, and it has a little bit of a natural gas smell or whatever, it's a gear lube. You're going to need to make sure you check with your manufacturer. If you do have a sail drive and you're changing your oil, you drain it from the bottom, but you have to go up top and take the cap off, the fill cap off, otherwise it's like poking a hole in something. It's not going to just drain. If it's a milk carton, you pop a hole in the bottom of it, it'll leak out a little bit, but if you release the cap, it'll just pour out air, you got that air in. Same thing happens with a sail drive.
If the nut on the bottom of the sail drive is really seized, any tricks to get rid of that?
Okay. If the nut on the bottom of the sail drive is really seized, is there any tricks to getting it out? Much like I was talking about with the fuel thing earlier, you have to have the right screwdriver. I've had that happen several times, not only on this, but on outdrives on power boats. I actually have a Craftsman screwdriver, and it's just a little short stubby one like this, but it's really big, and so I keep it short so that I keep grip on it. So when I grip it, the one that I have has square flats on it. I can hold it in place and use a crescent wrench or a wrench to get the extra torque I need. That's the way I've got, and I've had some pretty seized ones, but that's worked every time. The other thing is they got a tool that is like a screwdriver, but you hold it there, and when you hit it with a hammer, it causes it to spin a little bit, because sometimes a little extra pressure against it will help break it loose. Yes, sir.
The transmission fluid on the older transmissions, when they call for, whether it was a GM or a Ford Type B or whatever,
Mm-hmm.
you can't get that, they no longer manufacture that type of transmission fluid that you've got.
Okay, so on the older transmissions,
I'm talking specifically, I believe it's a Dexron.
Dexron 3, yeah.
In a, earth transmission that the older Cadillac.
Okay, he's got an older Hurt transmission that called for Dexron 3 transmission oil that they no longer make, and so what can you use? You have to read, and you can get it certain places, mostly from only the marine dealerships. Even the transmission we have in there says it's compatible with Dexron 3 or for Dexron 3, but it has to say compatible. The other thing you can do is you can switch to the newer transmission fluids, but you have to completely evacuate the entire system. So not just your transmission, the cooler hoses, everywhere it goes through, and then you can switch it to work with the newer transmission fluids. But they are not compatible with one another is the problem.
Okay, so when you say evacuate completely, again, going back to the little Earth transmission with the numbers on it,
You must have a universal
yes.
HBW
I
or
think
something.
it only holds, what, a half a pint?
Yeah.
It's very little, so how much do you have? I mean, you can suck most of that out, but do you have to have that completely evacuated?
Okay, what I would do in that instance is, he's saying that it only holds a little bit, and so he's asking how to completely evacuate it. In that instance, I would drain as much as I can. You're right, get to the very bottom of it and drain as much out as I could. And then I would probably put half a pint of diesel fuel in there and leave it sit. And then I would suck the diesel fuel out because the diesel will eat up the extra lubricants that were in there, and then you can put the proper stuff back in. I've done that on, believe it or not, a whole totally different discussion, but we have, believe it or not, over the years I've been here, had one or two boats maybe get a little lower in the water than they're supposed to be. And so when we pickle the engines, we do the same thing. We use diesel because that'll take the water out as well. And then, you know, in the actual oil some. And then we fill it back with the proper oil. This is yet just another chart that better helps you explain the passages that the oil takes and the pressures and the direction that it goes and all of the things that it lubricates, cools, conditions. Just some little signs. This is the stuff you see on your oil cans or your oil bottles, if you will. And then that's what I was telling you earlier about using oils that are oil filters that are designed for your engine. They're designed like that for a reason. That's just a Yanmar thing because I did a lot of training with them. That's how together them and I wrote this seminar. So only use filters recommended by the engine manufacturer, as I said. Any other questions on lube oils or transmission oils? I'll get to you in a second. Yes, Barry?
I use full synthetic, and I change it every fall. But after I change it and then run the engine, the oil never is really clean looking or clear. It's always black. Is that pretty standard?
Okay. He said he uses synthetic oils and every time he changes his oil, after he's done, the oil still looks black, and is that consistent with diesel engines? Yes and no, okay? Depending what type of engine you have and what their clearances and tolerances are that are allowable, is how you're gonna get that. This gentleman back here with the Perkins engine, you can change that oil 4 times and it's still gonna be black. I know it's good clean oil because I just put it in there, but that's just the nature of the beast. That's how it happens. Westerbeek is a lot like that as well. Some people have gone to the synthetics. Once again, I'm not going to tell you what to use. You need to look at your owner's manual and use what your engine manufacturer recommends. They are starting to become more familiar with synthetic oils being used. But like I said, the biggest thing, and I hate to push this, but if you are under warranty, definitely use what your manufacturer says, whether you believe it or not, because they will not cover warranties. Had it happen on a cooling system on a boat a few years back. You just, even though it doesn't make sense, Yanmar had a recommended we switch from the green ethylene glycol to the red extended life antifreeze for everything because of the chemical makeup of it. So we have an extended life antifreeze that we didn't change every year like the owner's manual said, and they wouldn't cover the warranty. To me, it seemed kind of ridiculous because we have an extended life antifreeze, but we still have to change it annually. It just didn't make sense. They are very sticklers when it comes to that kind of stuff. You had a question, Beck?
Running the sailboat diesel engine. And what they said is you should be running it under power, high RPM for a minimum of 4 hours a month.
Okay.
And
So he was saying he attended McMorran used to do classes where they would come here, or they would go other places and do it. And he said that they recommend you should run your diesel good and warm and hard 4 hours a month. And so I was saying weekly or monthly, you should go weekly, I said, like I said. Yeah, under power, that's a good point. And under power because all the components are moving and doing what they're supposed to do, they're really gonna cause that engine to get as warm as it needs to be. Did you have another question back there?
I'm a little confused about, running the engine, and, I've got a Catalina, 38 footer, and, a Yanmar engine, a 3J4, and, so, if I'm just, cruising in the lake, I may run it at 2,200 RPM or something like that.
Okay.
And when I'm under power, and I want more power, I probably run at 25. But max to the wall is like about 3,000 RPM. So what level should I be running it at? Is it okay just to jam it all the way to the wall or run it at 3,000
Okay,
RPM?
so his question basically, it's about his motoring speed or motoring RPM, if you will. There is an optimal range where the engine is designed to operate between a certain RPM, and that'll be specified in your manual. If you go wide open throttle, that's not gonna hurt anything, okay? It'll definitely heat the engine up, but you don't wanna stay up there at a continuous time. And the whole reason being what I just said, and it specifies in your owner's manuals, there is an optimal running speed between certain RPMs that when the engineers make the engine, they design it to be run between those RPMs. But wide open throttle is definitely needed in the event of an emergency or if you do want to get it up to a certain temperature. It's there for a reason, but there is a designed operating RPM and it's different on every engine. You got to go by the engine manufacturer. That's where I would stick, and I would say where you're at, you're probably within that range.
I was just gonna say that, I will push it all the way to the wall, and I'll watch my temperature gauge. And when it starts going over that 180, I just bring it down to 5.
Okay,
And
there,
it's fine, but it gets it nice and hot.
yeah, Barry was mentioning the fact that he does take his up occasionally to wide open throttle and he'll keep an eye on the temperature gauge. He says when his starts getting 180, he'll bring it down. We're getting ready to talk about cooling systems here in just a second. And so you need to remember that if you have a fresh water cooled engine, which means you have antifreeze running through it, that's usually inside that tank with it all sealed off, it's in a vacuum. So the temperature can get to 210, 212 degrees without that stuff boiling. Number one, because of the makeup of it, and number two, because it's under a vacuum. So we'll talk about that in a second. Any other questions on lube oil? I just want to thank you guys. You're all asking great questions. I'm sure somebody else is thinking about it, and it really, I could stand up here and talk all day and it would be nothing. I really need the input from you guys. So, also with that said, I forgot to mention in the beginning, you'll see critique sheets. Please make sure you fill them out. That's the only way that I can better what I'm doing and better what Larson Marine is doing for you guys as a boating community. So now the cooling system. Automotive uses airflow over water for cooling, and the marine uses water, either direct water or water over fresh water. Now, if you're in my seminar last week, I mentioned to you how in the marine industry, fresh water is considered antifreeze. Like you would think of your radiator on your car. On this, it would be called either a surge tank or a coolant tank. So the freshwater cooled engine is one that has antifreeze in it. A raw water cooled engine is one that doesn't have antifreeze in it. And we do have both kinds out there. Okay? I'll let you read that if you can for a minute. I'm going to tie my shoes so I don't hurt myself. As far as your cooling system is concerned, we have the Seacox, as we were talking about earlier, okay? We have a strainer. You should have a Seacox, and then a strainer, and then this hose should go up and go to the inlet side of your raw water pump. A raw water pump has an impeller that spins inside a brass housing, creates a suction, pulls water up through the engine. As you can see here, sometimes you have a strainer on the outside of the boat. Once again, old configuration, but I leave it this way just to remember the importance of there should be a seawater strainer in here, okay? Because anything you suck through there can get into here and cause that impeller to go really bad, which we'll talk about in a minute. Then it'll go, on this instance, this is a freshwater cooled engine. The water will go through the heat exchanger. As you'll see, it goes through here. It goes through the inside of these tubes. Your antifreeze goes inside this tank, which is on the outside of the tubes. The colder raw water below you is now cooling the freshwater antifreeze in the cooling system, okay? After it passes through here, then it goes into your mixing elbow. The mixing elbow, and on this engine, it's right here, and you guys can look when you come up in here so you can see, has an outer piece, which you see here, and an inner piece. The exhaust comes out of the inner, and on the outer, there's a hose that water injects. And then the water goes out the back of the boat, as I mentioned earlier, and that's what keeps that. So on your car, you have your exhaust pipe that goes all the way to the back. On your boat, you have a rubber hose. So the water then goes through the rubber hose, keeps the exhaust cool all the way out. Sometimes you have a muffler in there that will help reduce the sound. And not only does it reduce the sound, this will come off, it'll go to a muffler, or they call it a water lift muffler, if you will. And what happens is the water will dump in, and it's basically a hollow spot, and then the pressure of the engine running will push it out a different way and out the back of your boat. Okay? I was talking about when you do your fuel and you turn it off, the whole reason being that engine's not turning over enough. You don't have the pressure to push that out, so it would back up. That's what I was referring to earlier. I just wanted to specify that. That being said, this kind of explains it again, okay? And so your antifreeze, as I said, I had a big issue with that at one point, so now I recommend everybody go to their owner's inspection form, tell them what it says. Yanmar, I can tell you, says you should be changing it annually. Once again, changing it annually is based on a boat that's in the water 24/7 all year round, being used all year round. That's what they rate the standard for. You don't realize how small Great Lakes boating is. You see all the boats we have here in Chicago and Milwaukee and everything, but it's actually very small compared to the amount of boats around the entire world. So they write the standard for in general, okay? So I have talked to Yanmar. I actually did this with a couple other manufacturers I've worked with as well, and told them I think they need to write a second standard, because I don't think, personally, you have an extended life antifreeze that you're using for 4 to 5 months a year. The standard should be different for boats that operate in not freshwater, non-salt water. I don't want to say freshwater and confused because of what we're talking about. Once again, just my opinion. Don't say Mark Kish said that I didn't have to change it, so I shouldn't have to buy an engine. That's not the case. Just my recommendation or my thought.
So you touched on this a little bit ago about the antifreeze and how they recommend to go to the extended life. That engine was built, they had the green stuff in there, it ran great for 40 years like that, now all of a sudden you gotta use the red stuff.
Okay, so his question is, you got a 4-year, basically, if you had a 40-year-old engine and was running with the old green stuff, and then they come out with a service bulletin that you switch to extended life, even though it worked perfectly fine, that's one of those that's your choice. What they found, and I have a service bulletin at my desk, but they found that as the engine continues to heat, and you'll see in a slide I've got coming up here shortly, the antifreeze will slowly start to build up on the outside, right here. You see this? These tubes? The antifreeze will start to build up on those tubes and not allow for proper heat transfer over time. The other thing they discovered is because of the chemical makeup, it starts to coagulate, if you will. It starts getting silicone balls that end up getting in there. And it doesn't just happen like that, but over time, it can. Not saying that it will, and possibly because we, as I just said, only use our boats a few months a year, might not be something that's been happening. But that was the whole purpose behind them switching from the ethylene glycol to the extended antifreezes that are out there. Yes, sir.
When you do change that, how often would you want to flush the system out?
He said, when you do change that, how often would you flush? Anytime I change it, I would flush the system out, just to make sure I pick up anything that would be in there on that.
With a flush with a soap?
Okay. What we do is we get a regular radiator flush from Napa, and you mix it with whatever the water is based on the size of your expansion tank or your cooling system. In your books, it'll tell you what the capacity of your cooling system is. You put the recommended amount in there, you run it up to temperature like Barry was talking about earlier, under a load, and then you shut it off and you drain it back out. Some of you have Yanmars, okay, or some of your other engines as well, and you may see on the side of the engine, of course it's on the other side on this one, but there's usually a small tube that runs down right here, okay? And there's something on the side of here that's knurled, and it's on this one, it's on this side. That's actually a block drain, okay? So if you're going to change your coolants, you're going to want to run your engine up to temperature before you change your coolant. If you don't do that, you have to come over here to your thermostat housing. You have to remove your thermostat, because the thermostat will not open and allow water to flow through all the passages of the engine until it's up to temperature, okay? So you can do it over the winter, but you need to pull this off and remove the thermostat. Once again, like the jug of milk I was talking about, you poke a hole in, or your sail drive, you have to take this cap off of here. Otherwise it'll drain and you'll only get a little bit out. You have to put the cap, take the cap off, so it allows air to flow through so that it'll gravity drain. Yep.
mentioned fluid gas also going through the water heater.
Oh, certainly, good idea, thank you. So, there's another place that a lot of boats have set up where your water goes through here and out the exhaust. However, there's some boats that are set up, you have your thermostat, and so this would be for your closed cooling side, which is in here, right? So you have let me specify, I'm glad you mentioned that, but you have a raw water pump and you have a fresh water pump. So you have the raw water pump that draws in the medium below the boat, and you have a fresh water pump that moves the fresh water, aka antifreeze, around all the components of the engine and just continues to cycle. And so what happens is, once it gets up to temperature, the thermostat lifts and allows it to go to other non-such vital parts of your engine. You also have on your thermostat, on the inlet outlet side, this one says bypass flow, hoses that will go to your water heater, okay? The reason for that being is your water pump, your potable water pump, runs off of the DC on the boat. And if you're underway and you're running your engine, the heat that's absorbed from the engine via the antifreeze goes into a water heater. Basically, you have a tank and there are coils that go around the tank. Water is inside it, and through conduction, the water that's inside it will get heated by the antifreeze that's flowing around the outside of that, and then it flows back and goes back to the inlet side of the thermostat. So, if you store outside and winterize by means of displacing the water with antifreeze, you're usually good to check it every couple of years. Reason being, there's a little bit of petroleum, if you will, not really petroleum, but antifreeze helps keep these tabs on your impeller a little more resilient. If you don't winterize your boat, you just leave this sit in there, it's now sitting inside a housing that's pushed down like this, and there's nothing to keep this resilient. I would just about guarantee you, if you pulled it out, it would still be bent even more than what these are right here, okay? Let me finish this real quick. So, this is Yanmar's recommendation each season with the extended life. Keep the seawater intake clean, and we call it seawater intake because it can be brackish water, Great Lakes water, I don't like to say fresh water because of the way they refer to the antifreeze as fresh water. Keep your belts and hoses and clamps tight. That being said, I want to say one more thing about hoses on your cooling system. Anything that's attached to the lake, anything that's seawater, being your intake hose, from your seacop to your strainer, from your strainer to your engine, and then the discharge hose that goes out the back of the boat, because depending, it's usually above the water line, but if you have a fouling T, you can get water in there. That should all be wire reinforced hose, especially on the suction side. If you use like a radiator type hose that's soft and spongy, what can happen is, and this isn't a good example, but it can completely collapse, and then you're sucking air instead of water, and you won't get the proper cooling, okay? What happens if this starts getting clogged, you don't have the proper flow of water, which you then don't have the proper heat transfer, and it's going to cause your engine to overheat. It's going to run great at the dock all day long, and you can run it up to 4,000 RPMs at the dock, and it's going to run fine at the dock all day long. As soon as you get on the lake and you're really using the propeller and pushing this boat through the water and it gets hot, running it up to temperature like Barry was talking about, that's when it's going to show and it's going to overheat. You're going to slow down, the overheating is going to go away. It's going to confuse the heck out of you. There's two ways to recover these parts. You can come back to the mixing elbow right here, take the hose off, and blow back water backwards, which would basically blow this way, and it would come out. Usually I would take the hose off at the inlet and blow any pieces back to recover them, or you can use compressed air. Sometimes there's no way about it. You have to take this cover off. Well, what happens is people will say, well, your impeller was burned up, and we changed it. And they'll send you a picture of your impeller. You think, oh, cool, I got a new impeller. I'm going to be on my way. Then you overheat like I was talking about, and this is what you have. It's kind of a close-up picture. I'm sorry, but this is the cooler. This is the passages that the water flows through. You're asking about the antifreeze and the different kinds. You can see on this where some of it's starting to turn green and stuff. That's some of them balls they were talking about that gets in there. Here I've got an impeller chunk sticking here. I've got one there. Got it in a few places. This particular one was missing 2 blades off of an impeller, just like this. Okay? When we pulled the cap off of the cooler, we found that. Well, you'll be able to see in this next picture, in fact. So, all those pieces were clogged in there. So if I don't have water flowing across through my cooler where my antifreeze comes in contact with, I now lose the cooling medium that I have, and it doesn't do the parameters that it should. So, that's the impeller. That's the rag we found in the strainer that caused the impeller to go bad. So you can see there's still a lot to that impeller, and it certainly wasn't all of that. So somebody before us had been in there and changed several impellers and never recovered the pieces. That's why I say it's so important. Don't hesitate to ask your repair facility to give you all of the pieces of the impeller, because if they're just giving you an impeller that's missing parts, they went somewhere, and there's a good chance, unless every single one of them is missing, it didn't get hot enough to disintegrate and go out the exhaust. Okay? That has happened. I'll get you in a second. We had somebody bring a boat over from Waukegan one time as well. And this is why it's so important when you start your engine to look over the back and make sure you have water flowing. Remember, I told you got that rubber exhaust hose that runs through your boat. You got a muffler in there. Sometimes they're steel, sometimes they're plastic, sometimes they're fiberglass. We had a gentleman start his boat to bring it over here. He got halfway here and said that his engine was overheating and he was taking on water. I knew immediately what the instance was. The instance was his seacock was closed, which caused the impeller to burn up. The exhaust got so hot that it melted a hole through the plastic muffler, and the water that wasn't going out the back was now filling the boat up. Okay? It's very important you pay attention to this stuff, because it happens in real life. It's bad. You know, I know it's easy to get out there and be having fun and not check occasionally to see if you got water coming out the back, but that is one of the most important things when you're running your engine, and you can check for it. That was a Vetus plastic muffler. Had it been a steel one or a fiberglass one, the muffler probably would have been fine, but the hose would have melted, and you still would have been putting water from the lake right into your bilge, okay? So please pay particular attention when you start your boats on that. And I had another question before you, behind you, go ahead.
Mark, do you think about replacing the exhaust every once in a while?
Okay, my question is, what do you think about replacing the exhaust every once in a while? Well, your hoses, not just your water hoses, every hose on your boat should be inspected annually. You should be checking it for dry rotting and cracking. You should be checking it for its resiliency and see what it is. It's a corrective action, but could be a preventive action. It all depends on how much attention you pay to it. You should be checking your oil. I know you're not going to want to hear this, but you should check your oil every time you run your engine on a boat. You don't know what's going on inside that engine compartment. You might shut it down. There might be something hot, like got super hot. A bolt could have rattled loose. A wire tie could have broken, put a hose against something there's a lot that can go on in there. Your car engine, a little bit different. You don't necessarily see it every day, but it's exposed, and it's exposed to the outside. So if something were hot or burning, you would smell that when you get out of your car. you've got an engine inside an engine compartment that has insulation around it to keep it quiet so you can hear yourself on the boat, you need to do these inspections. So that's all I have. I thank you for your time. Please fill out the fatigue sheets. I really need those, okay?